Hello again, and welcome to 4.6. So we've been working with imaginary numbers and complex numbers. Now we're going to start dividing them, and we'll learn a little bit more about how they work. So let's get started. All right, here we go. So as I mentioned, we're going to be dividing imaginary and complex numbers. So hopefully at some point in your life, you remember that whenever you have a fraction, you can't have a radical sign or a square root in the denominator. So in that situation, you would just rationalize the fraction, or you would multiply the top and the bottom of the fraction by a fancy version of 1. It's usually the square root of the denominator over the square root of the denominator. And that would just take that rational number and put it on the top of the fraction. And mathematicians like that a lot better. It's easier for us to do math with them. We have computer programs that can handle that a little bit better. So in the same way, hopefully you remember that we're dealing with imaginary numbers, or i's. By definition, I is the square root of -1. So that means that we cannot have an I in the denominator because it's a square root. So we have to do something to get rid of it and to move it into the numerator without breaking any math laws. So the process to do that, it's not terrible. You are just going to be multiplying by a fancy version of 1. Hopefully you remember that like any number divided by itself is 1. So like 5 over 5 is just 1. So we're going to pick I over I. And then we're multiplying. That's the easy one. So we multiply across the top. You multiply across the bottom. And so now we have 10i over 2i squared. And still, I hope that you remember that I squared is the same as -1. So our fraction reduces to we'll say equals 10i on the top and 2 times -1 on the bottom, which then of course means 10i on the top, -2 on the bottom, and we can then simplify this, and it turns into -5i. So this is our new rationalized fraction. So anytime you see a denominator that just has an I and nothing else, no plus or minus another term, you're just going to multiply by I over I, and that's going to make that bottom I cancel out, and you're good to go. So if we were to do number 2, we're going to multiply I over I, multiply across the top, we have 4i, multiply across the bottom, we have -9i squared, which sometimes I like to just take a different color and cross that out and change my sign. It reminds me that, hey, I see the I squared and that turns into a -1 multiplied by the number that it's attached to, just changes the sign. So our final answer is 4i over 9. 4 and 9 can't reduce anymore, so we're good to go. A couple more examples. We've got I in the denominator. We're going to multiply by I over I, a fancy version of 1. Multiply across the top, we got -7i. Multiply across the bottom, we've got 5i squared. I love using my different colors because it helps me stay organized. So now we have -7i over -5, which then equals a +7i over 5. That is a perfectly acceptable answer. It is an improper fraction, but we are totally cool with it. That's fine. So what gets a little bit more interesting is when you have multiple terms on the top, but it's not terrible because you're just going to distribute whatever number you end up multiplying, the same thing as you would always do. So again, same process, multiply by I over I. So we multiply across the top. If I rewrite this, it would look like I times 28 minus 8i. So that's what's actually happening, and that's kind of a better way to write it to make sure that you distribute the I. On the bottom, it's just going to be 4i squared. Use my different color. So now let's deal with this top. So this I is going to go into this one and that one. And then what we're going to have left over is we're going to have 28i minus 8i squared over negative 4. We got an I squared. We're going to change my sign there. And then all of these are even, so I can reduce all of the numbers. Remember, when you're reducing fractions, if you're pulling something out, it has to be every single number in the fraction. It can't be just one of them. So like I can't cancel this out like that. I have to include the 8 as well. So if I pull, I don't know, a 2, so that's going to be 14, 4, and then 2. I can pull another 2 out. Told you 2 is my favorite number. 7, 2. So now what we have left over is we have 7i plus 2 over negative 1. So I'm just going to distribute that negative to both of my numbers up here. And that is basically my answer. If I wanted to rewrite it, make it look pretty, well, okay, if I'm going to rewrite it, might as well do it right. I would just do negative 2 minus, oh my gosh, minus 7i. Either answer is fine by me. I know what you mean, so that works. 2 more quick examples. Here we've got a 2i on the bottom. You don't actually have to multiply by 2i over 2i. I over I is just fine. That will get rid of that I in the denominator. So that's what we're going to do. We're going to save ourselves a little bit of math. So the I gets distributed to both parts right there. Then we're just going to multiply across the top. So we've got I times 1 is I, plus I times 4i is 4i squared, all over 2i squared. So my I squared is going to change the sign here. My I squared is going to change my sign in the denominator. So what we have left over is we have, I'm going to put this negative sign up there, which would mean I'd have to distribute to both numbers, just because it's a little weird down there at the denominator. So we're going to have a positive 4i, no, just kidding, a positive 4 minus I over 2. And again, this negative sign I put up to both of these, and that's why the sign switched. All right, so this next one, again, same process, I over I. So we distribute this. We're going to have negative 8i minus 2i squared all over 6i squared. Our i's are going to cancel out and turn some signs the opposite direction. So now what we're going to have left over, again, this negative sign is going to get distributed up into the top. So we are going to have, what is that? Negative 2 plus 8i all over 6. I can pull a 2 out of them, all of those things again. So this is going to be 1, 1. This is going to be 4, and this is going to be 3. So then what we have left over, we got negative 1 plus 4i all over 3. So there you go. Okay, so for number 7, we have a different situation. So the first case is kind of the easy case. It's just a number times I. So that's when you're going to multiply by I. If we did that here, then that I would just be in front of the 5, and we would still have an I in the denominator. So we have to use a different method to get that I out of the denominator. So if you would recall back to our previous lesson, we found an interesting characteristic with complex conjugates. Remember, a complex conjugate is, if I were going to find the conjugate of this one, it would just be 5 plus I. So I just changed the sign on the inside of there. So if we use that property or that interesting thing that happens with complex conjugates to deal with this, the fancy version of one that we're going to use is 5 plus I over 5 plus I. And then, sorry, my clock was going off in the background. I didn't want y'all to listen to the whole thing. Okay, so let's do the math from this problem here. So remember, this is kind of all in parentheses. Okay, so we do the top multiplying across the top. That -2 hits both numbers. So we're going to have -10 minus 2I over. So now, if we're going to have to FOIL this bottom one out. So we're going to have, let's see here, 5 times 5, which is 25. 5 times I, which is positive 5I. Then we're going to have negative I times 5. Negative 5I. Oh, gee, that's interesting. Negative I times positive I is going to be negative I squared. So, do you see what happened here? When we put these two together, they go away. 5I minus 5I is just 0. Don't have to worry about it anymore. Also, I squared is the same as -1, but it's already negative, so it's going to be a positive 1. So then, after we do all that stuff, what do we have left over? We have -10 minus 2I. That's all the stuff from the top. Didn't touch it. And we can combine our 25 and our 1 into 26. So from there, it's just a normal fraction. We've got my favorite number that we can pull out. So we're going to pull out a 2. So we've got a 5, 1, 26 divided by 2 is 13. So then, all things left over, -5 minus I over 13. So that's the trick. Find the complex conjugate, multiply by your fancy version of 1, and then math. So if we were to try number 8, let's do that. So again, our complex conjugate is just going to be the opposite sign of that denominator. So we're going to have 6 minus 2I. 6 minus 2I. And then we're just going to multiply that out. So on the top, we're going to have 5 times 6, which is 30. 30I minus 10I squared. And then we're going to FOIL this bottom one out. So 6 times 6 is 36. 6 times -2 is -12I. 2I times 6 is positive 12I. 2I times -2I is minus 4I squared. So then from there, we've got an I squared. Let's change our sign. Got another I squared. Let's change our sign. And then we're going to combine our 36 and our 4. And then what we have left is 30I plus 10 over 36, 37, 38, 39, 40. 40. I can pull a 10 out of that, and I'm just going to switch these numbers just because, you know, mathy people like that. So if I pull a 10 out, we're going to have 1, 3, and 4 left over. So that means we're going to have 1 plus 3I over 4. And there you go. Again, the trick here is just finding this complex conjugate and making sure that we algebra correctly. So if we look at number 9, we're going to look for our complex conjugate. It's going to be opposite of that sign. So it's going to be 4 plus 3i over 4 plus 3i, and let's do some math. So 3 times 4 is 612i, plus 3 times 3i is going to be 9i squared. And then on the bottom, we've got 4 times 4, which is 8, 16. 4 times positive 3 is 12i. Negative 3 times 4 is negative 12i. And then negative 3 times positive 3 is going to be a negative 9i squared. Okay, so we're going to go through, change our signs of our I squareds, and on our next round, we'll combine those two things, and what do we have left over? So we got 12i minus 9 all over 16 plus 9 is going to be 25, right? Yeah. And that's kind of it. Okay, number 10, we've got our fancy version of 1. Again, remember, we are just, for the complex conjugate, we are just changing this sign, that middle sign right there. We don't care what that sign is. The math works out either way. So our conjugate is going to be negative 3 plus 5i over negative 3 plus 5i. So here we go, down the math hole. 2 times negative 3 is negative 6. 2 times 5 is 10i. It's an awesome looking eye. Negative 3 times negative 3 is 9. Negative 3 times 5 is negative 15i plus 15i minus 25i squared. Go through, so these guys cancel out. Our I squareds change signs. And then what do we have left over? We're going to combine these guys. 25 plus 9, 36. So we've got negative 6 minus 10i over 36. From there, we can pull out my favorite number in the world. Number 2. It's the only even prime number. So we're going to have 3, 5, 18. I knew that. I was just testing you. And that's going to kind of be our answer. So we're going to rewrite it. Make sure it's all pretty and stuff. So it's going to be a... hang on. I made a mistake. So if you look right here, I tried to cancel out an I, thinking that it was an I squared. It was not an I squared. So let's fix that. Whoops. Oh, whatever. So this should be a plus because this never happened. So watch your negative signs. But still, our final answer is going to be negative 3 plus 5i all over 18. Okay, some more examples. Multiply by the conjugate. Negative 4 minus 8i. Negative 4 minus 8i. So then we're going to multiply across the top. Negative 7 times 4, negative 4, whatever. I said that wrong. Negative 28i minus 7 times 8 is 56, right? Yeah, so yeah, I knew that. 56i squared all over positive 16, 4 times negative 4, negative 4 times negative 4. plus 8 times negative 4 is 32i minus 32i minus 8 times 8, which is 64i squared. Our i's are going to cancel out. These are going to cancel out. We'll combine this. And what do we have left over? We got 56 minus 28i over 64 plus 16, 80. From there, we can't pull a 2, but we can also pull a 4. So let's do the 4. So when we pull the 4 out, 56 divided by 4. Yeah, we can do that. 14, 28 divided by 4 is 7. And then we've got 20. So what do we have left over? 14 minus 7i over 20. So then number 12, our complex conjugate is going to be 2 minus i, 2 minus i. So the only difference here is that we're going to have to FOIL this top one. So we've got 7 times 2, and then 7 times negative I, and then 3i times 2, and then 3i times negative I. So here we go. 7 times 2 is 14. 7 times negative I is negative 7i. 3i times 2 is 6i. There should be a plus there. 3i times I is negative 3i squared. And then we've got 4 minus 2i plus 2i minus I squared. Our i's are going to change some signs. We're going to combine these two. And what do we have left over? We got 14 minus I. So I combine these two. Oh, I forgot a 3 in there too. Where's my eraser? There it is. So 14 plus 3. 14 plus 3 is 17 minus I all over 4 plus 1. These guys cancel out, which is just going to be 5. So there you go. Okay, these last 4 examples, I want you to try yourself. So pause the video right now, try the examples, and I'll put the solutions up here in just a moment. All right, here we go. How'd you do? Did you get the right answers? So we've got our negative 3 plus 2i over 2. Our conjugate was right up there for 13. 14, here's our conjugate. Here's our answer. Oh no, I forgot to circle it. And then 15 and 16, here are the answers. I want to see if you can do them yourself and then check your work. So hopefully you got plenty of practice. If not, we'll go over more of this in class. But we also wanted to go over some of the complex and real number properties. Now, this is not something that I'm going to test you on, but it's something that you need to know either way. But you're not going to have problems like this. So if you remember, back when we learned properties of numbers, so we had this thing called real numbers. Well, now our box just got bigger because all real numbers are within this bigger box of complex numbers. So basically our number line has gotten bigger and more complex. So within our complex numbers, we have pure imaginary numbers. That's like 5i, 6i, 37i. It has an I attached to it. And then we have complex numbers, which is both an imaginary number and a real number all together. So that would be like 5i plus 4. Those are our complex numbers. But our real numbers are still members of complex numbers. And then all of this stuff still applies. They're all members of this thing, this set of numbers that we call complex numbers. So there's a whole lesson here, but we're going to just glance through it. All of these things, if you remember, commutative property of addition, associative property of multiplication, distributive property, identity property of multiplication, and inverse property of addition. If you treat I like a variable, it is all the same. It is all the same. So that's why we're going to kind of glance over this section, because we're going to use this stuff a whole bunch, but just treat I like a variable. That's it. Until it gets into I squared and then turn it into a -1. If you remember that I is a variable, I squared turns into -1, you are good to go. All of this stuff is the same. So nothing has changed. We just treat I like a variable. Okay, so we went over 3 main things, right? Number 1, how to rationalize an imaginary number in the denominator. That's when you're going to multiply I over I. How to rationalize a complex number in the denominator. That's like 2 minus 4i. You're going to multiply by a fancy version 1 of that conjugate. You're just going to switch the sign in the middle and multiply by that over that. And then 3, we went over the properties of complex numbers, which again are just the exact same as normal numbers, except we're going to treat I as a variable, and when you square it, it turns into -1. That's it. That's the lesson. So from here on out, I will see you in class.